So our unit on quadratic functions begins with vocabulary. That's all today is. Quadratic functions, like I said, are going to be all of the things that you've done when you've thrown something up in the air and it's come back down to you. Okay, so let's write that word down. Quadratics are in the form, circle this for me, f of x equal to ax squared plus bx plus c. Does this look familiar to you? Oh my gosh, it should.
It does.
It does. Isn't that just what we were using for polynomial arithmetic to do the factoring? Great. The reason why we did all of that is because that helps us solve these quadratics. We're going to get to that eventually. But today we're just going to be working on the vocabulary. So again, functions of the form f of x equal to ax squared plus bx plus c are called quadratic. The graph of a quadratic function has the shape of something called a parabola. P-A-R-A-B-O-L-A. Don't say parabola.
Parabola?
No, parabola.
Parabola.
It's very tempting to say parabola when you see the way it's spelled, but it's parabola. Say the word parabola.
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 Not parabola, parabola. Okay, a parabola has a lot of important vocabulary words that we need to know. So we're going to label all of these important vocabulary words here on this picture so you can see where they are. The very first thing we're going to do is this box. Where is this box up at the top pointing to?
The line.
Describe this line.
Where across the x-axis?
This line crosses the x-axis. It's vertical. Is it really there, or because it's dashed, is it kind of like imaginary?
It's imaginary.
Okay, great. That is called the axis of symmetry. Do y'all know what the word symmetry means?
Yes.
What does it mean?
A line. Like a... Similar?
Similar in what way? Describe it. Like, don't think math. Just think these two things are symmetrical. What are you talking about?
Exactly the same.
Exactly the same. They're like folded. So if you look at your hands and take your hands and fold them like this and then unfold them, your hands are generally symmetrical. Yes, like your fingerprints are different. Yes, like your wrinkle hands are different. But like generally, they're symmetrical. They're reflections of each other. They're exactly the same on each side. That's the same thing as an axis of symmetry. Do you see how it cuts this parabola, this U shape in half to where this side is exactly like that side?
Yep.
That's called the axis of symmetry. Okay, where is this box pointing to? The y-axis, specifically at what? The y-intercept. Very cool. Quadratics also have y-intercepts. Just like with all of our other functions, that's our initial value. That's where our parabola starts. So when you throw the football, you are the y-intercept. When it leaves your hand, that's when it starts going. That's the y-intercept. It's my initial value. These two are going to be the same vocabulary word. Where are they pointing to?
Zero.
The x-axis. They're pointing to a y value of 0. There are 4 words that can be used pretty much interchangeably for this area.
Domain, X-Intercept.
I like that we're going to call them the rocks words. R0XS. And I'm going to draw a line through them to help us remember that they're where they hit the horizontal line. So R, 0, X, and S. Those words are roots, zeros, X-intercepts, and solutions. What does the R stand for? Roots. What does the O stand for? Zeros. What is the X? X-intercepts. And what does the S stand for? Not state. Solutions. Okay, great. There's 4 vocabulary words that can happen at these 2 points. You have one last one. What is this box pointing to?
The line.
The bottom of the curve. Do you see how this parabola has like a turning point right here? It has like an elbow?
Yeah.
That's called the vertex. Say the word vertex. Vertex. Now that vertex can either be... Okay, now this vertex, because it's a lowest point, are you going to call it, just think about the words, since it's low, are you going to call it a maximum point or a minimum point? Ooh, what does the word maximum mean? Tallest, biggest. What does the word minimum mean? Lowest or smallest. So this vertex is a minimum. Your graph will either have a vertex that is a minimum or is a maximum. And the reason that's important is because we're going to need to be able to tell the lowest value it goes to. How low or how high does it go? So how low does this graph go?
-4.
-4. That's its minimum value. That's as low as it goes. That's going to be super important for us. Okay, so let's write a little bit more definitions for these things down. You have all the words here in this little chart. you have the roots, the zeros, the x-intercepts, and the solutions. That's again called the rocks words. I probably, at the door next time, will ask you to tell me what rocks stands for.
No.
So let's remember roots, zeros, x-intercepts, and solutions. This is the location where the graph crosses the x-axis, or the points that are partnered with a y-coordinate of 0. Then you have your y-intercept. It's the location where the graph crosses the y-axis. There may be 2 x-intercepts. There will always only be 1 y-intercept, period. The vertex is the highest or lowest point on the graph. We're also going to be calling it the turning point. So it's when the graph changes from decreasing to increasing or increasing to decreasing. Then you have the axis of symmetry. That is the vertical line. It's invisible, but we know it's vertical, so it's a Vux line that passes through the vertex and separates the graph into 2 equal parts. The equation is always x equal to some number. We're just going to use h as a placeholder right there. X equal to h. Last but not least, we have our maximum or minimum value. When I'm asking you for the max or minimum value, it has to do with that vertex. So these 2 pieces go together. And we're just trying to know the y-coordinate of the highest or lowest value in the parabola, or the highest or lowest point in the range of this function. Okay, so axis of symmetry is invisible vertical line, cuts it in half. Y-intercept is where it crosses the y-axis. My rocks are where it crosses the x-axis. And my vertex is where it turns. Those are the vocabulary words I expect for you to know how to identify after today. Is that cool?
No.
Yes.
No. Oh, great. If it's cool, let's turn this paper over and let's do some example problems where all we're doing is identifying this vocabulary. All right, so this first problem, again, all we're going to do is identify all of these pieces. Because we're learning, we're not just going to write down the answers, we're also going to label this parabola. Okay, this is a happy parabola. Do you see how it's smiling?
No.
That's a happy parabola. We can have happy parabolas. If we look at the second example, what do you think I call that one?
So.
Yeah, this is a sad parabola. You got happy parabolas, which looks like smiles, and you got sad parabolas that look like frowns. Sad parabolas happen more often in real life. Because if you look, this is like throwing a ball up and it coming back down. So sad parabolas are actually more common in real life. But we have both kinds of parabolas that we can deal with.
Happy parabola.
A happy parabola is what we're starting with, yes. Okay. X-intercepts is the first vocabulary word I want to identify. Where do I find the x-intercept? Here and where else? 1. Now here's the thing. So we're going to label these right here, the x-intercepts, but it actually has 4 names. What were the letters of those 4 names? R, 0, X, and S. So we're just going to label it because like the more we label, the more we learn. The x-intercepts, yes, are the numbers you told me, but x-intercepts, you need to give it to me as a coordinate. So the first x-intercept is -3, 0. The second x-intercept is 1, 0. Okay, that's the x part of rocks. The zeros, however, are literally the same thing, except you don't have to tell me it as a coordinate. The zeros, you can say -3 and 1. Like you could just put the word "and" in between them. Yes, we're talking about the same place on a graph, but when you answer these questions, x-intercept you're supposed to answer with a coordinate, and the 0 you can just answer with a number. Sound good?
No.
I want that to happen. So if I ask you for an intercept, x or y, it should be a coordinate. Okay, I'm about to ask you for the y-intercept. Where do you label that on your graph? 0, -3. That is my y-intercept. Very good. So 0, -3 is the coordinate point of my y-intercept. Vertex. What did we say the vertex was? Like where on the graph? The highest or lowest point. A way you can remember that is look at the V in vertex. You see how it has like a little bottom? We're talking about the turning point of the graph. So we're going to label the vertex right here. Vertex. What's that coordinate point?
-1, -1.
-1, comma, -4. Very good. Now, this vertex, is it a maximum or a minimum? Minimum, because it's the lowest point. So we're going to circle minimum, and then we're going to say what that lowest value is. How low does it go? -4 is the lowest it goes. So my minimum value is -4. Now, axis of symmetry. What did we describe axis of symmetry to be? The line that goes between it goes right through the middle. It goes right through which point? Well, what's the vocabulary word that it goes through? Ooh, starts with a V. What does it go through? The bottom. What's that bottom called? Vertex. Yeah, it goes through the vertex. And then we just need to look for the number on the x-axis which it hits. What number does it hit? So our axis of symmetry is x equal -1. If you answer just -1, that's wrong. It's an equation. It has to say x equals and then that number. It has to say x equals and then that number, or else it is wrong. Now, why is it x equals and not y equals? Because it's going through the x-axis. It is also a Vux line, and Vux lines start with x equals. Okay, cool.
Where did you get that red line from?
I drew it in.
Why?
Because it's my axis of symmetry, but it's not actually there. We just know that that cuts it in half to make it symmetrical pieces. I could fold this graph along that dotted line. It would land right on top of each other. Okay, this next one's for you to try. I want you to try to label all of the pieces for this one. You got it. All right, so let's do this sad parabola down here. First things first, since the x-intercept is where it crosses the x-axis, how many times does this cross the x-axis?
One time.
Well, it touches it once, so it crosses it one time. We actually only have one of the roots, zeros, x-intercepts, and solutions. It should be at 2, 0, which means y2, that's the coordinate point that if I plotted that over 2 up none, boom, it's right there. If that's the case, what is the 0? 2.
2 and 0.
Oh, 0? It crosses at 0?
Oh, no.
No, so remember, the 0 is just a number. It's the first number in your x-intercept coordinate. What is the y-intercept here? 0, -4. Very good. What is the coordinate of the vertex?
2.
Oh, that's a whole number. Let's talk a coordinate. 2, Very cool. It's okay if your x-intercept and your vertex are the same point. That's going to happen a lot.
Oh, well, that's one.
Uh-huh. Now, is this vertex a maximum or a minimum?
Maximum.
Maximum. And how high does it go?
2.
It goes to 2?
0.
Oh, it goes to 0. Remember, the maximum talks about how high or how low it goes. This highest value is 0. So my maximum value is 0. What is the equation of the x-intercept, or sorry, axis of symmetry?
2x equals 0.
Ooh, not just 2. X equals 2. Here's something that's really interesting. I want you to look at both the first equation and the second one. In the green and the red, do you notice something about this answer and these answers? And then this answer and these answers?
Yes.
What about it?
You take the 0, put it down, and then you take the 2 and put it down.
So the y coordinate of the vertex is your maximum minimum value. The x coordinate of your vertex is where the axis of symmetry shows up. That's going to happen every time. The y coordinate of the vertex is the max or min value. The x coordinate is a part of my axis of symmetry. That happens every time. So that's a quick check method for you in your brain to make sure that you're getting these right. Okay, let's do some creative problems here. We want to sketch the graph of a quadratic function with the following characteristics. It has a minimum value. So let's go with Raul. Does that mean that this is going to be a happy or a sad parabola? It's going to be a happy parabola. Very cool. All right, the axis of symmetry is x equal to 3, AB. Does that mean I draw a vertical or a horizontal line here? Do I draw this one or this one? The first thing I drew or the second thing I drew? The vertical one. Okay, so I'm going to draw this vertical line. I'm going to make it invisible, meaning I'm going to put these little dots in between them. That's my axis of symmetry, x equal to 3. And then it says it has exactly 1, 0. What does that mean for it to have exactly 1, 0? Say again? It's, oh, I see what you mean. How many times can it cross the x-axis? Once. And where is it going to cross, Yannick? It's going to cross at 3 because that's where we need it to be. So it doesn't really matter how wide you draw it because it didn't give us much information so long as you cross only at that 0. You could have made it real skinny. You could have made it a little skinny parabola, but I decided to make mine large and in charge. It is a minimum value, has an axis of symmetry at x equal 3, and has 1, 0 instead of 2. Another creative problem for us here. There's 5 statements and only 3 of them are correct. I want to give you a little bit of time. Can you find the 3 correct statements? Okay, hold on. So the quadratic function is graphed on the grid. Which of the statements are true? Choose 3 answers. The first thing says the function has 1 positive and 1 negative, 0. Where do I find the 0 on a graph?
Nowhere. Oh, yeah, X, my bad.
The X-Intercepts. Does it have a 1 positive and 1 negative? 1 positive and 1 negative?
Yes.
Okay, that one's true. The next one says the axis of symmetry is y equal 1.
3.
If I were to graph y equal 1, it would look like this. Is that where the axis of symmetry is?
No.
No. What should that say? Instead of y equal 1, it should say x equal 1 to make it a vertical line. So that one's not true. The third one says the minimum value of the function is 1. Is that as low as it goes?
Yes.
For real? That's how low it goes, is 1? How low does this go?
4.
Negative 4. So that's not correct either. Remember, you're looking for the y value. It's like how tall or how small you are. Right, okay, thank you. The minimum value, you looked here and you saw 1, right? That's the right point to look at, but you're looking at the y-axis. Actually, how low is it? Not how wide is it, but how low is it? Its lowest is negative 4. The next question says the vertex of the graph is located at 1, negative 4. Is that correct?
Yes.
Okay, fabulous. And then the y-intercept is located at 0, negative 3. Is that correct?
Yes.
All right, so we've got the 3 correct statements about this. Very cool.